Hello guys, I'm Aishwarya. Welcome to Aishwarya's Math Classroom. In this video, we are starting class 9 Max with the book Ganita Manjari Part 1. Our first chapter is Orienting Yourself, the Use of Coordinates. Before we start the exercise, let us understand the concept with real life situation. So let's get started. So our first chapter, Orienting Yourself, the Use of Coordinates. I'm starting with 1.2 settling in. Here you can see a real life situation is given. I'm going to just summarize this for you. It's about two siblings, Rian and Shalini. They have just moved to a new city and they are going to attend their new academic year in a new school. And Rian here is a blind person. He cannot see. But moving to a new place is not something new for him because he has done this before because his mother's job is a transferable job and it has been easier with each move for him. Shalini, who completed grade 9, thought this time she'll guide her brother Rian by applying coordinate geometry. So what she did is she creates a rectangular grid on the floor using pins and thread. Each point on the grid represent a position in the room. By connecting this point with thread, Rian can feel and understand where things are placed. So basically, this example shows how coordinates help us locate positions clearly, even without seeing them. Here you can see figure 1.1 sketch of Rian's room. Over here you can see one door. Over here you can see the door to the bathroom. This is a bedroom. Okay. Then wardrobe is there. The bathroom, this bathing area is there. Then the left side of the bathroom, left wall of the room, then right wall of the room. So this is basically the sketch of Rian's room. Let us examine figure 1.1 to understand the layout of the room. Notice that this only shows a map of the floor. Do you see why the position of the windows cannot be marked on this map? It is because this figure is a 2D figure. In 2D figures, you can't see the windows. For that, we need a 3D figure because the height portion that can be seen in a 2D figure. Okay, I hope you understood. Now let's move on to the next page. 1.3, the 2D Cartesian coordinate system. In the chapters on integers, rational numbers and decimals, we have studied number lines which is one dimensional. But in 2D dimensional, the coordinate system uses two lines. One line is horizontal. This line is called the x-axis and a vertical line is called the y-axis. The point of intersection, this point is called the origin and the coordinates are 0, 0. The distance to the right of O or upwards, this right or upwards are considered positive and the distance to the left and downwards are considered negative. I will explain this using the figure in the next page. See figure 1.2 structure of coordinate plane. Here you can see the horizontal line which is the x-axis and the vertical line which is the y-axis and the point of intersection O and the coordinates are 0, 0 and towards the right we consider it positive and towards up also consider positive, then towards left and downwards consider negative. I hope this figure is clear to you. Now let us go to the next page. See point B, you can see the coordinate 4.5 comma 0. This point lies on the x-axis, so y is 0. Now if you take point G, the coordinate is 0 comma minus 4.5. This point lies on y and it is downwards, that is negative 4.5, and here x will be 0. When the point lies on the y-axis, the x will be 0. If you take h, the coordinates are 0, 4. Here the point lies on the y-axis. So x is 0 and the point here of y is 4. Coordinate of h is 0, 4. Then the h here it is written as 0, comma 4 and we can also write it as h 0, 4. Both are same. This is also correct. See here you can see if x is negative, p lies to the left of O. A point P is equal to 0, y lies on the y-axis. If y is positive, P lies above O. If y is negative, P lies below O. I hope this is clear. Now let us move on to the next page. Now let us start with the exercise part. Exercise set 1.1. Here figure 1.3 shows Rian's room with points O, A, B, C. A and here B and C. With points O, A, B, C, the x and y axis are marked in the figure. Point O is the origin. See here, point O is origin. That means from this origin towards this right side is the x-axis and upward is the y-axis. That is, the vertical line is y-axis and the horizontal line is the x-axis. I hope the figure is clear. Now let us move on to the questions. Now, referring to figure 1.3, answer the following question. So here the figure is given 1.3. The first question is, if D1 R1 represent the door to Rian's room, how far is the door from the left wall of the room? How far is the door from the x-axis? Now, if you look at the figure D1 R1, this represents the door to Rian's room. The coordinate of R1 is given, that is 11.5 comma 0. It's y is 0 because this point lies on the x-axis. The coordinate of D1 is not given, so we will find it out. It is 8 comma 0. The point again here y 0 because the point lies on the x-axis. Hmm? So how far is the door from the left wall? This is the left wall, and you have to find how far this door from the left wall. So this distance we have to find. So first I'll just write the coordinates, that is d1 is equal to 8 comma 0, r1 is equal to 11.5 comma 0. Now if you look, the how far is it? It is 8 units. So we can write it as the door is 8 units away from the left wall. So the door is 8 units away from the left wall. And how far is the door from the x-axis? Now if you look, the door is exactly on the x-axis. So if it is on the x-axis, how far is it? It is on the x-axis, right? So it will be 0 unit. We can write the door is 0 unit away from the x-axis. Hope you understood. Now let us move on to the next page. Second question. What are the coordinates of D1? Which we already found in the first question, right? D1, it is 8 comma 0. So we can write the coordinates as D1 equal to 8 comma 0. Now we'll move on to the next question. Third question. If R1 is a point 11.5 comma 0, how wide is the door? So here we have to find the width of the door. Then, do you think this is a comfortable width for the room door? If a person in a wheelchair wants to enter the room, will she be able to do so easily? So here the door is from D1 to R1. The coordinates of R1 is given, and we know the coordinate of D1, which is 8 comma 0, and we have to find the width of the door. Width of the door equal to how much? D1 equal to 8 comma 0, R1 is equal to 11.5 comma 0. If you subtract 11.5 minus 8, you will get 3.5 units. Okay, so the width of the door is equal to 3.5 unit. Okay, do you think this is a comfortable width for a room door? Yes, it is comfortable for a normal person. If a person in wheelchair wants to enter the room, will she be able to do it so easily? So I don't think it will be. They can easily get into this room if the person is on a wheelchair. So I'll say well, this is not suitable for a wheelchair person. So you can write, but not suitable for a wheelchair person. I hope you understood this question. Now let us move on to the next question. Now, fourth question, if B1 0, comma 1.5 and B2 0, comma 4 represent the ends of the bathroom door. So, if you look here, this is B1 and B2, and the coordinates are 0, comma 1.5 for B1 and 0, comma 4 for B2. This represents ends of the bathroom door. Is the bathroom door narrower or wider than the room door? So here we have the room door, and we already had find the width for this one, which is 3.5 units. Okay, so first we'll write the coordinates b1, which is equal to 0 comma 1.5, and B2, which is equal to 0, comma 4. So to find the width of bathroom, we'll subtract 4 minus 1.5, which is equal to 2.5 units. And the width of the room door, which is 3.5 unit. So when you compare this both, the width of the bathroom door is narrower. Okay, smaller, right? So we can say it is narrower. I hope you understood. So we completed all 4 questions from exercise 1.1, and the remaining exercise questions will be done in separate videos. So if you like my videos, please do like, share and subscribe. Thank you.